Guys, so as promised, I'm making a quick video just to remind you how to graph a quadratic function that's in vertex form, just in case you're working on your homework and you get a little stuck on a certain section. So this example is actually just coming right from the homework. It's actually going to be example 6 from the homework. So if you watch this video, you should at least have this first example done. So the original function that they're giving you is g of x equals the quantity of x minus 3 squared plus 2. Okay? So within our vertex form, first thing we're always looking at is a. Now, if we look here, we don't technically have a coefficient of a. Just put an imaginary 1 there. So since it's a positive, we know that it's going to be an upward-facing parabola. So we can identify that just to make sure that we're graphing this correctly. From here, we are going to identify the shifting. So remember, whatever's inside the parentheses is representing your horizontal shift, and we're shifting the opposite direction of the sign. So since this is x minus 3, we're actually going to shift towards the right 3. Now the outer portion is representing our vertical shift, and this is where we stay true to the actual sign. So to find our vertex point, we're going to shift from the origin, right 3, up 2. So if we look, we start with our origin. We're going to shift to the right 3, up 2, and we're going to draw a point. So this point here is what we call our vertex. So if we were to identify that vertex, we would say that that point is at the ordered pair 3, 2. Now from here, we can draw our axis of symmetry. And remember, this is that imaginary vertical line that is actually cutting our parabola in half, making it symmetric. If we wanted to identify what that axis of symmetry was, remember, vertical line is created by an equation x equals, and it's going to be x equals 3, same exact x value from our vertex. Now from here, in order to get your next point, this is where we have to do a little bit of a thought process. So we're going to create a little chart just to organize our information here. So we have our x value. We're going to have our function, which we're going to take x values and plug it into. And then we're going to have our ordered pair, x and y. So when you're picking x values, remember, you're trying to pick x values that are close to where we already have a point, which is at your vertex. So at our vertex, we have an x value of 3. So if we were to pick an x value that's close to that, we would pick an x value of 2. So if we look, 2 is directly next to that axis of symmetry, right? So from here, we're going to take that value of 2 and plug it into our function. And we're just going to simplify. So 2 minus 3 is negative 1. Negative 1 squared is a positive 1. Positive 1 plus 2 is a 3. So we're going to graph that ordered pair, 2, 3. And remember, once you have one point on one side of the axis of symmetry, since it's symmetric, we can draw the same exact point on the other side of the axis of symmetry. So now, just by identifying one additional x value, we now have 3 points. So to find our fourth point, we're going to do the same exact thing. We're going to pick another x value. So I'm going to use the x value of 1. Take it, plug it into my function, and simplify. 1 minus 3 is negative 2. Negative 2 squared is a positive 4. Positive 4 plus 2 gives us 6. From here, I'm going to graph it, represent the mirror image point, and then as you can see, I have my 5 points representing my parabola. Now we're just going to connect the dots. Nope, not the best there, but you get the picture. And you have just graphed the parabola. So hopefully if you have any questions, this video helps clarify it. If not, just make a little note of it and we'll talk about it tomorrow.